Hey everyone, this next video is going to be showing you how to calculate the travel time for water that would be moving from the highest point in your watershed down through the stream network and out to the watershed outlet. So the way we're going to do this is by using the drawing tool to draw our flow path length. So we're going to first start by going to where it says line in our tools. We've got our Warrior Mark Run watershed up right where we left off in the last video. You can see the high points and the furthest point away from the watershed outlet is all the way up in this top corner here. So we're just going to start drawing from the very tippiest top of this watershed as best as we can through the stream path or through the stream network, so that would be our flow path, all the way down to the watershed boundary. And you can kind of be fast here. It doesn't need to be perfect, but definitely follow the lines as best as you can quickly down through the stream network, all the way out to the watershed point of interest. Definitely is a very meandering stream here, huh? Lots of back and forth. Okay, so double click once you've got to the point of interest and you'll kind of be able to barely make out this file that you just made. So you can double click on the picture and you'll be able to see its length. So that's the first thing that you want to know is what's the flow path length, and make sure that you're picking the units in feet. So if you see other units, go ahead and change them, because the calculation that we're going to do for the travel time, the Kirpich method we're going to use the Pennsylvania specific version of the Kirpich method. So it's got a little bit different numbers in it than maybe you've seen if you worked on these calculations outside of Pennsylvania before. But we'll go ahead and use this flow path length as the flow path in the Kirpich method equation. And we also need to know it for the slope, because the slope is rise over run. So that's the change in elevation that's occurring over this path length. So go ahead and jot your number down. Your number might be a little bit different than mine, but hopefully it's somewhere around 60,000. So I'm going to use my flow path number. I just have a little Excel file open off to the side here, but you can go ahead and put this on your calculator or wherever you're doing your calculations, and just jot this down so you have that number ready when you're going to do your calculations here in a little bit. So I'm going to hit symbol now so that I can change this so I can see it better. Just make this red. It doesn't really matter which color red you pick. And I'll expand the width diameter to about 2 so that my flow path length is nice and bright on my map here. Okay, so now we know the next step is to get the slope. So we're going to use the identify tool to get the elevation where we started our flow path and then where we ended our flow path. So go ahead and click somewhere on your map close to where this top corner is. And you'll see, because our DEM is not the topmost layer, it's not going to be very happy at first to give us that number. So we have to tell it which number or which layer we want to pick from. So I'm going to switch to WDEM, which is our Warrior's Mark digital elevation model. And you might have it called something else, but either way, make sure you're picking from your DEM. And if it doesn't automatically change what number it was giving you, then you'll need to re-click on your map, and then you'll see your pixel value. So mine's 519.68, so we can just round to 520. So that's going to be the high point on my map. So I'm just going to type 520 off to the side here as my top. And then if I click near the bottom, we should actually be able to just use this low number. But if you just want to see how this is done, again, click somewhere near where your point of interest is. And I'm getting just about 270, so you could use this low number. I'm just going to stick with 270. It's going to be pretty close. Our goal is to get the slope, right? So we just need to know the change in elevation over the change in length. Okay, so that means I've got a high of 520 and a low of 270 here. So now I can do my flow path calculations, and I'm going to stop sharing the screen and pull up a blank PDF so that we can start working through these calculations together. So let me switch my screen here and bring up my PDF reader. Let's see, gotta make sure I find the right one. Okay, here we go. So I've already written out the time of concentration calculation. So this is the travel time from if a water droplet were to hit that flow path length in the very topmost corner of our watershed, how long would it take for that to get down to the watershed outlet? So I'm gonna grab my trusty pen and my little trackpad editor and go ahead and write with you. So our length is our flow path length. In units of feet. And you should have gotten around 60,000. So my number was, let's see, I had gotten 59,607 feet. And then my slope is rise over run, where my rise is my difference in elevation. So my top one was 520 feet. And then my bottom point was 270 feet. And that's going to be divided by the run, which is 59,607. And that's going to give us our slope in units of feet per foot. So let's see, 520 minus 270 gives us a difference of 250. So that means I've got an elevation difference of 250 feet over a distance of 59,607 feet. So now what I'm going to be able to get is the average slope that water is going to be moving across. So that difference of 250 feet happens over 59,607. So that gives us 0.0042 feet per foot. So that's a pretty gradual change in slope. That's a pretty flat landscape then, because that, if we multiply by 100, is about 0.4%. All right, so that's not very steep at all. That's a pretty gradual slope. So now we've just got to figure out the travel time. So our travel time calculation with the Pennsylvania specific numbers, so that would be this exponent here on the flow path length and also on the slope, are unique to Pennsylvania. So if you're somewhere else, make sure you're doing your calculations with different exponents, so you will need to look up what those are. And so my flow path length, let's see, 59,607 to the 0.77 power. And that's going to be divided by our slope of 0.0042 raised to power of 0.5, so basically the square root. So if I quick do that calculation, if you do it along with me, 0.0013 times 59,607 to the 0.77 power. Okay, so that top part there gives me 6.179, so about 6.2. And if I divide that, my denominator is 0.0042 to the 0.5. And so I get that my travel time, remember your answer is going to be in minutes, so I'm getting 94.2 minutes. And so that is just a little bit more than an hour and a half. So to go all the way from the top part of our watershed, if I stop sharing here and go back to my GIS map, you can see basically to go from here all the way down to here takes about an hour and a half. So if you got that, nicely done. All right, thanks for watching.